We will call the last speaker is Enver. Okay, is here. He will present the presentation named Evaluation of Precipitation Simulated over Middle Latitude Land by CPTECAGCM Single Column Model.
Okay. My name is Sandro Ramirez. I'm going to present an evaluation of precipitation simulated over mid-latitude land by CPTECAGCM single column model. Well, the purpose of this is the abstract of the study. We developed a single column model of the AGCM CPTEC model version 4 as a tool to calibrate a new physical model. In this particular study, field experiments like ARM, TOGA, Chuva, BOMEX, LBA. Some of those experiments are also being performed. Well, this is an overview of our presentation. We talk a little bit about the single column model, then talk about the cloud resolving model, the observational data we use it, and then we will show some experiments, and finally a summary. Well, our single column model, as I said, was derived from the AGCM CPTEC version 4. And the model is basically forced with a vertical component of the velocity and the tendencies of U, V, T, and Q. The model, the options for physics inside the model are boundary layer, 3 options, Melor llamada 2.0, Melor llamada 2.5, Hochschlag-Bovill, modified by Paulo Kubota, 3 options for surface processes, SSIB, SSIB2, IBIS, deep convection. We have several options, but for this study we basically used Kuo and Grell de Benji. Shallow convection is by Tietke. Large scale precipitation adjustment is one option for large scale, and the other is microphysics from Rush and Christensen. Gravity waves are from Alper. Short wave radiation used in these experiments are from ClearRat. Ocean fluxes are 2 options also. Well, the cloud resolving model we use it is the SAM cloud resolving model developed by Marat Kaironov. The cloud resolving model I use it is an elastic no hydrostatic model and can be configured in 2 options, as a less model and as a cloud resolving model. The difference between these 2 configurations is that in less mode, the criterion for cloud is any condensate different than 0. And in the case in cloud resolving model, the criterion for cloud is 1% above supersaturation. We use here the cloud resolving version, the cloud resolving model version of this model. Well, more details of the CRM that are not relevant. The observational data we use it came from 2 sources. One is the Min Huang Sang Varana data. That is an objective analysis for the ARM case, and the other source is the Marat Kaironov. Both are 3 hours. Here we show in the top panels the observational data, and in the bottom panel 2 simulations with the cloud resolving model. One with a more simple microphysics, and the other with a more complex microphysics. And we can see the cloud resolving model is simulating quite well the observational data. But also we can see that there are uncertainty between the simulation of the cloud resolving model, represented by the green and the blue lines. The uncertainty can be more than 12 hours. Well, with this, we can see that the cloud resolving model is representing well the observational data. Here is a series of experiments with the AGCM 1D in blue and with the cloud resolving model in red. Okay, the scales of the AGCM 1D are on your left, and the scales of the cloud resolving model are on your right. You can see that initially our AGCM 1D is producing too high precipitation. Okay. Also, other problem that we find in the AGCM 1D is that it triggers precipitation at the start of the simulation very early. But there are some parts that the AGCM 1D is reproducing well, like for example this part, that the cloud resolving model shows that there is a diminution of the precipitation, and the AGCM 1D is showing that tendency. Other very bad result is over here. We have very few precipitation, but the AGCM 1D is showing a lot of precipitation. Okay, so we decided to use the variables of the cloud resolving model to reconstruct, to mimic some triggers used in the AGCM 1D. For example, here we can show a decapit trigger. Okay, here, column maximum max flux, and here we construct the TKE-Cine trigger and decapit TKE-Cine. Okay, we see that these two triggers represent better the trigger of precipitation. So we decided to translate these triggers into the AGCM 1D. The TKE-Cine is based on the Fletcher-Bretherton scheme. That is basically an equation like this, that depend of an exponential of the convective inhibition over TKE multiplied by the square root of TKE. And the decapit TKE-Cine, this trigger on the right, okay, is basically computed in this form, where T and Q star are modification of this temperature and moisture due to large scale advection. Okay, and the trigger is like this. Okay. Then we implemented that trigger TKE-Cine in our 1D, and immediately the scale, the intensity of precipitation was reduced. Okay, but we can see a lot of triggers of precipitation yet. For example, here. And that is a characteristic that you can also see here in the cloud resolving model. A very often triggers of precipitation. Then, when we implemented that decapit TKE-Cine over on the AGCM 1D, we obtained this result that we think that it's better from the two previous one. Okay, but still we have problems. Okay. Okay. Well, in addition to the precipitation, we also evaluate the diurnal cycle. Okay. Here we are showing the two simulation with the cloud resolving model. We see that the precipitation is mostly overnight. This is the radiation. Okay, so this is the day. Okay, here we can see that the precipitation is mostly occurring over nighttime. Okay, then we made the same evaluations for the previous triggers, and these are from the two triggers that we believe are better than the previous. We can see that in addition to the correction of the intensity, we also obtained a correction of the nocturnal precipitation. And these two compared with the previous triggers. Okay, well, so precipitation intensity is improved. Better results are obtained for the blended scheme that makes sure DKP and TKE and CINE. But I'm not quite sure if these results can be extended to other areas. That's why we say that even when precipitation intensity and diurnal cycle are improving, we need to answer this question. Are these improvements valid for other regions? Maybe we can obtain it, right answers by wrong reasons. Okay. Currently, we're working with the same time of analysis with the TOG experiment, but also we want to work with the Shuba data to do the same kind of experiment. Well, I like to acknowledge to the Red Clima Project for the financial support, and to the ENST for climate change who supports my participation in this talk. Well, finally, many thanks.
No, it's calculated. It's calculated. For that, yes, calculated. No yet. No yet. We want to make a series of experiments for different areas, just to understand different conditions, and then try to move to the 3D model.